Hello everybody. There is one more thing I forgot to mention about the laminar and turbulent flow, and this is something that would seem to be a little silly, but it's very important. So looking at these videos that we watched last video about the difference between the shape of laminar flow and turbulent flow, it might give an impression that laminar flow is more favorable than turbulent flow. And by favorable or not, I will be focusing here on the applications that will be including fluid flow, and whether these applications would be or will favor more the laminar flow or the turbulent flow. So just to make things clear, I'm not sure if I mentioned this before or not, but the flow regime has very big impact on not only the losses and not only how the fluid flows. It has impact on other phenomena like the heat transfer, the mass transfer, and sometimes the reaction, the chemical reactions that take place. In many cases, they are very dependent on how the fluid flows. Although the laminar flow looks nicer and looks more elegant than the turbulent flow, but in reality and practically, we prefer to have turbulent flow than laminar flow in engineering applications. For instance, if we have a device or a heat exchanger, for example. A heat exchanger is an equipment that we use to exchange heat between two different fluids. One of the things that we make sure or we design to achieve is to have turbulent flow inside this heat exchanger. And the reason is the mode of or the flow regime has very big effect on the rate of heat transfer. And that's something you will see later if you take heat transfer courses and mass transfer courses, that the rate of heat transfer equation has Reynolds number in it. And as the Reynolds number increases, the rate of heat transfer increases, and also the rate of mass transfer increases. So this is something that we try to achieve during the design, that the flow is turbulent and the fluid flows in a turbulent regime to achieve higher heat and mass transfer rates. And sometimes as I told you, the reaction is limited by the rate of mass transfer, so this also can affect the reaction rate or rate of reaction in some catalytic reactions. So although laminar flow looks better as a figure, but in reality we intentionally do the designs to force the fluid to flow in turbulent regime, as I said, in heat exchangers, in distillation columns, in extraction columns, absorption columns, in stripping columns, and in a lot of equipment. It's a must that the flow will be turbulent. And if we don't do this, then the rate of heat transfer and mass transfer is not going to be fast enough. And this means that we need to keep the process of separation or heat exchanging go for a very long time, and this is going to be economically not feasible. Or we need to make a very big heat exchanger with a large surface area so that it can achieve the desired heat transfer, which is also economically not feasible. So this is why we prefer the turbulent flow, and we design the fluid to flow or the equipment that the fluid flows in a turbulent regime to achieve this high rate of transfer that will make the process economically feasible. So I just wanted to make this point clear before moving to the next point in this chapter. So I'll see you then, inshallah. Goodbye.